It's the first slot at the conference. I'm really happy to be here and talk with you about serverless with Kubeless. Just to do a bit of expectation management, what do you expect from this talk? Do you expect a bunch of weird command lines and a shitload of YAML? Do you expect architecture diagrams? Do you expect memes? Okay, I got one for you. And actually, I skipped the command line part because going through code and so on, it's basically you can do at home. What I would like to do is I would like to talk a bit more about concepts and how we are using function as a service frameworks on top of Kubernetes to build for our customer an extension platform. In serverless extension platform, and yes, you might, based on the topic of the talk, we are using obviously Kubeless for that. So before we start, we have to get the legal stuff done. Everything I'm telling you is a lie, and if you don't take it as a lie, don't sue me if it's wrong. So I have to say this. About myself, I'm working at the SAP customer experience. It is formerly known as SAP Hybris. So we are responsible for everything related to the customer relationship. So SAP Hybris is coming out of the area of e-commerce, but we also have solutions for marketing, for sales management, and so on and so forth. Basically, I started with containers about 4 or 5 years ago and running Cloud Foundry. And by this, I also had to dig into Golang, so we use the open source version of Cloud Foundry, which means we had to really know what's going on there to maintain and support it. And while I'm not working on containers, I really love robots. So if you're interested to talk about robots, containers, Kubernetes, Cloud Foundry, whatever, just run into me. I'm here the entire 2 days, and I would happy to chat with a beer about those things. So let's get started. What is serverless? Who knows what don't look at the quote. Who knows or has already an idea what serverless is? Okay, there are still a few who are not raised their hands. So this is a definition by the definition maker Martin Fowler. A serverless architecture relies solely on a combination of third-party services, client-side logic, and service-hosted remote procedure calls. What does it mean? I did a painting for it. First architecture slide. On the one hand, we definitely have a set of third-party services. This could be simple, basic services like database as a service, but also could higher-level services like a commerce suite, for instance, in our case, but also services like identity and authorization management, and so on and so forth. On the other side, we have the client, which could be a web client based on JavaScript, as well as some mobile phone clients, and so on and so forth. And to glue all this together and to bring your custom magic sauce into it, we have a function as a service solution, which could be AWS Lambda, but could be also Kubeless or whatever. So the key takeaway you have to do for this introduction is function as a service is not serverless. So if you're running a function as a service offering, it's great you're running a function as a service offering, but don't call it serverless, because for serverless you have to have more. Because just to imagine, you're running a super easy to use function as a function, and but then you still have to operate a database with upgrades, disaster recovery, HA scaling, blah 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 blah. There is no big benefit about this function as a service. So only the combination of services and functions makes the difference. And now we have to ask ourselves, why should I build a serverless platform by my own? Because there are those guys available. And if you compare, they're super cheap. So just imagine one employee costs by average 120,000 euros a year. So you have to save money for at least 120,000 a year to employ one person who is running your serverless platform. And by using one of those guys, it's probably the way more cheaper, way more reliable, and you've got a better quality. So why did we decide to still build our own serverless platform? And the reason is we have a couple of products like enterprise commerce, Hybris marketing, or now it's called SAP CX marketing or something like this. Sorry, it's not up to date. And we have a lot of other products, and we somehow need a place how to integrate these products. And so to integrate all these products, to integrate them also with third-party solutions, with services provided by the cloud providers. So for instance, if we are running our solutions on Azure, to integrate also services from Azure, we built Kima. And the good thing about Kima is it's not there yet, so it's in the beta phase right now, but we are discussing about open sourcing it. So at least major parts of Kima will be open sourced, hopefully this year. Let's see how the discussion is going. And so what is Kima? Kima is a cloud-native extensibility framework to develop developed to overcome the challenges of digital transformation. Who is using? It's kind of a mission statement, so it has to be not easy to understand. So who is running Kubernetes or using Kubernetes? Was it easy? I will call you. We need somebody who thinks it's easy. So at least if you start with Kubernetes, you go through some tutorials and it seems to make sense, and then you go into the details. You have to have a lot of things to have monitoring. You have a lot of things to consider, which network layer you're using, and so on and so forth. If you then bring also stuff like Istio in there, it's even get more complex. And as our customers, they have a real business to do, so they should not care too much about the platform, about all the components you can stick into Kubernetes. So the idea is that we make this entry, that we lower the bar to entry the world of cloud native. And by doing this, serverless is definitely one of the choices. So how does Kima look like? So we decided to be cloud native. Even furthermore, we decided to be based on Kubernetes, which is great. Otherwise, I wouldn't be here probably. So with Kubernetes, we got microservices for free, so you can basically deploy whatever service you like. On the left-hand side, we have our own services, so Hybris commerce, marketing, and so on. With the deep integration on the right-hand side, we have kind of third-party services. Even SAP Cloud Platform is still SAP, but they are not that tightly coupled. They are more loosely coupled. They should be at least consumable out of Kima. So the next thing we like to add, or to make it a serverless solution or platform, we have to add a function as a service provider, or function as a service utility. We also, and this is something I will skip for now, we also have to have a gateway to have this tight integration with our own solutions. This gateway brings a message bus, takes care about authentication and authorization between the systems and so on. So I won't talk about this. It's maybe worth another talk. Then we added Istio, because if here is a trusted relationship, we also like to have the trusted relationship between all the components inside Kima, and also use Istio to expose it. And if you know Istio, there is, I guess, in the next slot, there is interesting talk about Istio. So please go there. It's super interesting, super exciting, because Istio is basically doing all the heavy lifting if you do build a cloud-native architecture. So it takes care about authentication, authorization, metering, monitoring, blah, 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 blah. So go there. It's worth. And the point is, now we have a set of uncoupled components, and we are using the open service broker to do the wiring between the different components. And I will talk about it later, but just for you to get an overview. Last but not least, we obviously need some UI and some CLI tooling. Especially for the CLI, we try to rely on kubectl, but also use the kubeless commands for the management of the functions. So what do we have to need? So first of all, we need a function as a service platform. These are a few of them which are available in the open source. We had a look, we did a market research, tried to figure out which one is the best fitting one for us. We did this, I guess, a year ago now, so many things changed in the meantime. For instance, we were almost done with the research, and then Riff was introduced. At least it's quite from Pivotal and part of their Cloud Foundry offering. So we haven't had a look on Riff. What I like to do now is I'd like to go through 3 of them because these are the ones we had a deep look into it. So first of all, OpenWhisk. Second, Fission, and third one is Kubeless. So OpenWhisk is kind of from the pre-Kubernetes era. So they build basically the scheduler by their own. So they have a server called invokers where they run Docker containers on. They have a controller based on Scala, and as soon as a request is coming in, they are fetching the function code out of the CouchDB, tells an invoker to run this, and on the second call, this invoker has this function pre-warmed, and the request is simply routed to this invoker and executed. One of the downsides is the main downside of OpenWhisk, or OpenWhisk is great if you like to build in multi-tenant function as a service offering. So they bring all the tenancy built in. They are kind of rock solid. I don't know, they're around for at least 3 years, I guess. So they're pretty solid and good to use. The downside is definitely, except of Nginx and Docker, most of the components are written in a JVM-based language. So it's not that lightweight, and also the integration with Kubernetes is not that good, as you can run OpenWhisk on top of Kubernetes, but there are 2 separate systems, so you have to build integration points between Kubernetes and OpenWhisk. So this was basically the reasons why we decided to not go forward with OpenWhisk. The second thing is Fission. I guess it's pretty well known in the community. Fission has a similar approach. The only thing the major thing they're doing different is they don't have this invokers. They run the functions inside of pods. So they have a set of generic pods hanging around, and as soon as there is a request coming in, they're assigning a function to this generic pod, making it a specific pod. And on this, so on the first call is probably slow, and on the second call, the function is pre-warmed, and it is fast. One of the things why we decided against Fission was the entire Fission thing is running inside one namespace. So it is kind of hard to apply all the namespace-based features to it, especially if you work together with Istio. The Istio networking rules are based somehow on namespaces, and this is a bit tricky to achieve with Istio, with Fission, sorry. Last but not least, Kubeless, the one we decided for. The benefit of Kubeless is it is super boring. So I tried several times to do a talk only about Kubeless, and I figured out it's 10 minutes and then I'm done. So the Kubeless CLI is creating a function and a trigger. So there are both CRDs. Triggers, there can be multiple. So for instance, there could be an HTTP trigger to expose the function to the outside. There could be a trigger for nuts, Kafka, blah, blah, blah. Functions, there are runtimes for Node.js, Java, Go, several more, Ballerina. I don't know if you heard about it. As soon as you created the function inside your namespace, the Kubeless controller is taking over. He's creating a deployment inside your namespace. And the init container is taking your function code, wrap it up, downloading all the libraries you need and so on. And then he is then the function is running as a simple pod, as a simple deployment. So there is, as soon as you're at this stage, there is no difference between a service deployed to Kubernetes or a function. So you can apply everything which comes out of the community to, or which is somehow in the scope of Kubernetes. You can apply it simply to Kubeless as well. Only downside is there is at least one pod always running. So this is not super good, but we are waiting for Kubernetes. They have at least some tickets hanging around to suspend pods. So as soon as this is possible, we also solve this resource usage issue. But yeah, this is a pretty small downside, especially if you focus on not so memory-heavy functions. That said, the trigger controller is doing the subscription, so it's creating an ingress for HTTP-based, or to expose the function, or it's subscribing to nuts, or to the Kafka topic, whatever. And then it's doing, as soon as the event arrives, it calls the function endpoint. It's based on HTTP, so as I said, it's super boring. It just works and pretty straightforward. But the benefit is Kubeless. The integration with Kubeless is with Istio is super straightforward. So the only thing we had to do is adding some annotations to the pods, and now the Envoy sidecar is injected. And as the Envoy sidecar is injected, we can do mutual TLS. It's not that easy, but it should work with Alpha 5, which is released a few days ago. And yeah, then we have a authentication authorization solved from Istio, as well as you can apply networking rules, RBAC rules, and so on and so forth. So this picture is out of the Istio documentation, so it's nothing new. Another thing is, who has heard about this Open Service Broker API? Not too many. One more. So the Open Service Broker API is or the Service Broker is an idea coming out of the Cloud Foundry space, and it is a super easy way, or the Service Broker defines how to create service instance. So it's a way. So the Service Broker is a way how to integrate third-party services into a cloud platform or into Kubernetes. So the Service Broker API defines an endpoint to create and delete instances. So for instance, to create a database or delete. And the second part he defines is a bind and an unbind. So that you can bind a service to an application. So as soon as you, for instance, the Amazon RDS Service Broker, on the create, it's instantiating an RDS database. And on the bind, it's created a user on the database and injects the information for this user into the environment variables of an application. So the Service Broker is a super easy way how you can attach services, whatever kind of service, to a function. So I really ask you to have a look on the Open Service Broker API, and also there is a Service Broker implementation for Kubernetes available. So because this is the easiest way I can imagine how you can integrate services which are not directly managed and without handing passwords, usernames, IP addresses from one hand to the other. So it's really, you just do the service binding, and then this information is automatically injected. So Cloud Foundry built the Service Broker. Kubernetes figured out at some point this might be a good thing for Kubernetes too. So at some point they met up and founded this Open Service Broker API standard. And now you get service brokers for Azure, AWS. Red Hat is participating to some degree. I already mentioned AWS. So there are many service brokers. There is also a service broker for Helm charts. So if you like to have, for instance, make Redis databases available to your users, you can also use this Helm broker and have a generic way how developers can request a database and bind it to their applications. And in our context, we are using the service broker all over the place. So we are using it to integrate with the blue boxes, the third-party solutions, as well as using it to set up the gateway connection and to set up network Istio rules to allow certain applications to talk to each other. So the service broker API is a pretty central component. Are you still with me? This was your meme. Where is it? I try to recap. It's the reason I guess part of the advanced talk is to confuse everybody. So at the end, we have Kubeless for function as a service. Sure. Gateway, we don't care. We have Istio to build a trusted relationship between all the different components. Also to do environment separations based on namespaces. So with Istio, you can simply define a rule that from namespace A to namespace B, there is no traffic allowed. And we are using the service broker to create new instances on one of the third-party providers, but also to establish to hand over the configuration from the service to the applications. Technically, it's done using pod presets, but yeah, that's pretty much a detail. How much time do we have still? 10 minutes. Okay. Oh, I'm too fast. Yeah, that's good. I have not planned with questions. So this is demo. This is I guess a nightly or a demo cluster. I don't know. This is how Kima looks like. So we have workspaces, so different environments. The environment is basically a namespace plus some metadata plus some extra configuration. And here we have the service catalog. Oh. Yeah, moment and show. That's great. Okay. Let's go back to the start. Environments, namespaces plus metadata plus some extra configuration. So for instance, you have to enable the sidecar injector from Istio. So this is basically preset in the environment. If you just create a namespace, you have to do it manually. So this is the service broker, the catalog from the service broker. So as you can see, we are running on Azure, or this cluster is running on Azure. So there are some services we are exposing from Azure, SQL database, Redis cache. We have these EC all events. This is one of our own services. So this is the enterprise commerce platform. And here's Redis provided by the Helm broker. So now I'm instantiating a new service instance, and this will tell basically the Helm broker to create a new deployment. So here are the service instances, and as you can see, the Helm broker is just creating a new deployment, new Redis micro. And how to use it, use Kubeless in this scenario, we are just creating a new Lambda function. We can select some trigger. And basically, this is abstracting all the Istio-related things away. So if somebody worked with Istio, it's, I don't know, just by having here a check mark, it will enable JOT token authentication. And last but not least, here in the service bindings, we can select our service instance. And as soon as this binding is created, we have host port and the Redis password available in my scope. I'm a bit sorry, I tried it till yesterday. We somehow changed something, so my demo was not working anymore, and I tried it till 1 a.m. today. So I cannot hit the create button, or I can hit it, but it won't make any difference. We can try return. So that you at least can see that there is that Kubeless is working. So I created the Lambda function, and Lambda is now creating a deployment. And hopefully, yeah, here you can see the pod out of the deployment. So now it's up and running, and wait a second. Let's disable the. Oh, now I can. Let's disable the jot token. This is live extending the demo, so. So fingers crossed it's still working. Yeah, so this was a pretty short function to expose some text data. If we have a look into the code, we are just returning, so it's a bit like AWS Lambdas for those who used it already. You have an event and a context input, and simply the return is forwarded to as a response. One thing to mention here, Kubeless is already compliant to the cloud events, to cloud events. So it's one of the first fast solutions which claimed themselves as compliant. So yeah, it should be also able to use it on different places. Here we go. Oops, sorry. So as a wrap up, Kima is built for serverless and so for functions and microservices, and as an extension platform for all our products inside the SAP customer experience area. The name changed a week ago or so I have to get used to it. We are using Kubeless as a function as a service solution, and the reason why we use it is super Kubernetes native, so there is nothing specific about it. It just works, and you can integrate it, and the integration path with basically all the standard Kubernetes solutions is the most easiest thing I've did so far. We are using Istio to cover the service mesh, to have authentication, authorization between all the services, for routing, for metrics, all the goodness you will see in the next slot. And we are using the Open Service Broker API for to do configuration between all the components, to do the binding between the different components, to integrate third-party solutions, as well as integrating own services into it. And in Kima there is much more. We haven't talked about the event bus. We haven't talked about the gateway. How we are doing this trusted relationship between the product and the Kima platform. So probably there will be more talks about it as soon as it is open source. That's all. Thank you for listening. And now we probably have some time, 5 minutes for questions.
Eins, zwei, drei? Eins, zwei, drei, okay.
Yeah.
So my question is, as far as I've understood, the container, the Lambda container is always running.
Yep.
I'm wondering why can't the trigger controller not run the initial container? What's the reason why the trigger controller cannot run the initial container for the Lambda function?
So the trigger controller is completely decoupled. It's nothing which is. So, for instance, we are not using any triggers. It's not part of Kubeless. And the reason is basically simplicity, because now we are simply creating a deployment. The controller code is not that big, and it's just working. And to be honest, if you have a look on at least some billing metrics of the big cloud providers, they are also keeping the function always on. So there are some providers which are charging you if you're not using your Lambda. So
Okay, thanks.
Somebody else? Over there, here.
So your beautiful architecture diagram displayed that you more or less map each and every function to a kubelet anyway. So why do you take this extra effort of doing all this architecture around it? Why not just using microservices directly?
So the reason is, how much work is it to deploy a microservice on Kubernetes? You have to build a Docker container. One-liner. You have to build a Docker container. You have to write a deployment. You have to write a service. You have to write an ingress. So YAML files. With Kubeless, you're writing the function code, and I haven't shown the command line. But at the end, you're specifying a few command line attributes, and you're shipping your function code. That's all. It is so. We are all in this world of containers and platforms, and we know how to write YAML files. But at the end, if you have a look on the most application level developers, they have different things. They work and think on a different level. They have to solve customer or user problems, and they don't like to dig into networking or anything like this. So that's basically the reason why this story of having functions is pretty appealing, because you really concentrate on your business code and don't have to think about all this wiring. You don't even have to run a server. So, for instance, on Java, you have to think if you're using Tomcat or Jetty. So it's basically the reason why I think this is definitely the way to go. 3 minutes. There was one other question. I don't think it's a good idea to have this to throw, because we are all IT guys and probably not that good at sport.
You said that you are thinking of open sourcing Kyma. When will that be appropriate? You don't know. No. So months.
What I can tell you, the important decision makers said it should be open sourced. So there are also blog posts from them out there. The point is, like in all bigger company, you have to go to certain processes, met some quality metrics and so on. So I can't say anything about it, but we are working on it.
Could you show us the first slide again, or the terms of services of your talk? Was this a joke or was it real?
Kind of. So the point is, I cannot give any commitments. I'm not allowed to, and I even don't know them. So if you got the feeling I did a commitment to do something, don't sue me.
Yeah, okay. No, I was just...
It's just a security thing.
The first time I saw this, and I found it a bit, ridiculous to have these terms of services in slides.
Yeah, there is a history about all the slides, so... Thank you.